In this video, we're going to try to prove that the series given by the general term 1 over 2 times n squared plus 3n plus 1 is convergent. We also want to try and compute its approximate value. Okay? So the key idea that we can see now is that this series is positive because the term let's call it bn or an here. This term here is positive. Okay, and we can use the p series test to say or to show that this one is convergent, because we can see clearly that 1 over 2n squared plus 3n plus 1 is less than 1 over n squared. Okay, and using the comparison test, so here this one from n equals 1 to infinity is bigger than this one, and this one is convergent. This is a p series because here we have 2 is bigger than 1. We know that we're using the criterion n to the power alpha is convergent if alpha is bigger than 1. So this proves that the series is convergent. Moreover, we want to prove want to compute its value using the integral comparison test. Okay, so what we do is we're gonna let an equals 1 over 2n squared plus 3n plus 1. Okay, and we're gonna let this one equals to some function fn. Okay, and we see the conditions here that this series with this term is positive. Okay, and also this function here is continuous on this interval 1 plus infinity. It's decreasing. Clearly we see it's decreasing, and it's positive. Therefore we can apply the integral test for series to show that the series is convergent or divergent, but we know it's convergent since we have already proved that it's convergent. We want to find an approximate value of this series. Okay, so the first thing that we're going to do is we're going to decompose this term here, this fraction, into two powers or two products that we have to decompose into fractions. Okay, so we note first that we can write 2n squared plus 3n plus 1 as we can do it as 2n squared plus 2n plus n plus 1, which we can write as 2n times n plus 1 plus n plus 1, and then we can have n plus 1 times 2n plus 1. Therefore, we can write this one here in terms of decomposition as 1 over n squared plus 3n plus 1 can be written as a over 2n plus 1 plus or minus, we don't know, but we put plus here, n plus 1. Now we cross multiply, so we're gonna have a plus 2b times n plus a plus b over 2n plus 1 times n plus 1, which is the same as this one. Now we're going to use this identification here. We don't have an a n power here, therefore we have a plus 2b is 0 and a plus b is 1. Okay, this first equation gives us that a is minus 2b. Let's plug it here. So we have, if we plug it here, we're gonna get b is minus 1, and therefore a is 2. Okay, therefore we have this decomposition as 1 over n squared plus 3n plus 1 is 2 over 2n plus 1 minus 1 over n plus 1. Okay, now we switch to the x. So this integral is, this sum here is equivalent to this integral here between 1 and infinity of 1 over x squared plus 3x plus 1 dx, which we know it's gonna be the limit according to the improper integral definition as x goes to infinity of 1 to t. I'm going to use this fraction here, okay? So 2 over 2. So let's use t. It's no problem here. 2t plus 1 minus 1 over t plus 1, okay? Everything dt. Okay? Now the primitive here is noun. So this is a log, okay? So I'm gonna have, let me move here. So I'm gonna have the natural log. So the limit as t goes to infinity, the natural log of 2t plus 1 over t plus 1 between 1 and, let me take x. Let's take x here. Let's do x between 1 and t. So when I do the computation here, I'm gonna get, let me compute the limit as x goes to infinity. So here between 1 and x. Okay, so it's gonna be the natural log of 2x plus 1 over x plus 1, okay, minus. So here when I have the 1, I'm gonna have the natural log of 3 over 2. Okay, so this is the, now when I take the limit here, since the natural log is continuous, I can enter the limit inside. So the limit of this fraction, 2x plus 1 over x plus 1, as x goes to infinity, is 2. Okay, therefore when x goes to infinity, I have this one, the natural log of 2 minus the natural log of 3 over 2. Now using the fraction here, I can invert it using this minus here to be the natural log of 2 plus the natural log of 2 over 3, and using the product I get 4 over 3. Okay, therefore this integral here is equal to 4 over 3, the natural log of 4 over 3. So this confirms one more time that this series is convergent. Okay, this is an approximate value, okay, of the series. Okay, I can compute exactly the sum of the series using some modification here. Okay, that's what I'm gonna do in one of the next problems. For now, we just verified that this series is convergent, and we found it's we confirmed that again using the integral test for series. We checked that this function, so let me write it again. F of x is 1 over x squared plus 3x plus 1 is positive, decreasing and continuous on this integral. And when I integrate that, I get ln of 4 over 3, and it's finite. Therefore, the integral test confirms that this series is convergent. Thank you very much.